Hi guys, before we get started, I just wanted to introduce myself. My name is Jess and I'm a senior at Coastal Carolina. This week we're going to be working with what's called the Shark Cam. Shark Cam is an underwater live streaming camera that is installed under Frying Pan Tower out off the shore of Cape Fear, North Carolina. So this picture in the bottom right is just Frying Pan Tower from above the water. But the camera is actually bolted to one of those beams that extends much further down into the water column. The camera's initial purpose was to educate the general public and to get them involved in the diversity of our oceans. However, this camera has been used for a lot more. There are projects at my university that collect data about fish populations and their abundance patterns, such as migrations. So today I'm going to walk you through your first worksheet in this curriculum. Also, a little fun fact, this link up here in the top right, is a link to the actual live feed of Shark Cam. So if you're interested or want to take a look at that, feel free. Okay, so before we jump in, I would like to do an overview of some basic external fish anatomy. These features of fish are some ways to more easily identify them on Shark Cam. I want to start with these 4 terms in bold that are around the fish. These are just general terms that are used to reference different angles of fish in general. The anterior is where the mouth is located, as well as the eye. The dorsal refers to the back or top of the fish, and you guys probably know that term from a dolphin's dorsal fin. All fish have them, as well as some marine mammals. The posterior refers to the tail or rear portion of the fish, and ventricle just means its underbelly. Some of the features you can use to easily distinguish fish on Shark Cam are the mouth, the dorsal fin, and the caudal fin. There's also this area right back here between the body and tail of the fish called the caudal peduncle. These areas are places where fish can have distinguishing markings or features or shapes that can help you distinguish them from other fish you see on the camera. These terms are pretty specific, and we won't go into much detail on them. I just wanted to run over those so you know where to look for those distinguishing characteristics later. You can also use these terms when describing your fish in your guidebooks. The main features that we will be describing in our guidebooks are coloration, body size and shape, behavior, and then we will also be coming up with hypotheses of the fish's lifestyle or their niche in the environment. So this is the first video clip y'all are going to watch. All of the videos that... So here's a close-up of our first fish. It is called the spot-tailed pinfish. I bet you can guess why. It's because of that big black spot on its caudal peduncle, which we talked about earlier. Other than that big black spot on its peduncle, the coloration of the spot-tailed pinfish is relatively shiny and silvery. Another defining characteristic is that large eye. The spot-tailed pinfish is also very thin when you look at it head-on, or from above or below. This thin body shape can also be called laterally compressed. This body shape is good for maneuverability. And why do we think that the pinfish would need to be able to maneuver through the water? It's because they are a smaller species of fish, and smaller fish tend to get preyed upon more. So, if they have the ability to move efficiently and skillfully through the water, they have a better chance of surviving. This body shape is also beneficial because predators above or below will have a harder time seeing the spot-tailed pinfish because it looks so skinny from the dorsal and ventral angles. Next fish is called the Spanish hogfish. It shows up a couple of times in our video, but it swims by for just a brief moment, so you may have not seen it. The Spanish hogfish is noticeable because of its vibrant coloration. You see that yellow with the purple dorsal area. Coloration can also range to just purple altogether, but most of the time the fish that you will be seeing have this coloration that you see in the PowerPoint. No matter what the color, all Spanish hogfish have this rectangular body shape with the squared off fins, which you can see here. They have a more rounded body type than a spot-tail pinfish, but they are still good at maneuvering because of their small size. I'm sure you guys are familiar with this next fish, the blue angelfish. It is characteristic because of its vibrant blue and yellow coloration. It also has a larger body size than a spot-tailed pinfish and a Spanish hogfish, but it is still medium in size. It also has an oval shape to its body, and fish that fit this description are called colorful ovals. Its body is also laterally compressed, which you can see in the video, which makes it good for maneuvering as well, which is beneficial because the angelfish is also a prey item. Now, this angelfish lives in close quarters with its cousin, the queen angelfish. It is important that we do not mix these up. Although they do have similar colorations, the blue angelfish only has yellow on the edges of its fins, while the queen angelfish has a completely yellow caudal fin and yellow pectoral fins. If you do mistake these two, that can throw your data off for the blue angelfish by a lot. So be diligent when you are going forward in this project not to mistake the two of these. I bet you guys also know what this fish is. It's called the great barracuda. This fish has a drastically different shape than any of the other fish we've looked at so far. It's very elongated and is also much larger. This one's probably about 3 or 4 feet in length. Now, let's think about what a barracuda is known for, and then think about its body shape. How are those two related? That's food for thought, and you should include that in your guidebook. The barracuda has an odd behavior that it displays most often on Shark Cam. You can see it hanging in the water column. They will literally just sit in one place and go with the flow, literally, watching their prey. These fish are also very silvery, but cannot be mistaken for much else because they are very distinct. You can also see these little rectangular looking markings along the side of them, which reflect in the light. That can easily help you identify them from afar. The barracuda also has that large mouth that you can see here and big teeth. That is also an indicator of their niche or lifestyle. The last fish that we'll be focusing on this week is the Atlantic spadefish. You can see that it has that oval shape similar to the blue angelfish, but its coloration is completely different. The Atlantic spadefish is silvery and has those distinct black vertical stripes along its body. It is also laterally compressed, which again makes it good for maneuverability. These stripes are the distinguishing characteristic of an Atlantic spadefish. Although they can be hard to see from far away on the camera, when they get close, it is easily identifiable. The shape of the Atlantic spadefish is similar to that of an angelfish, so the two can easily be confused from far away. However, as you become more well-versed in identifying fish, you will easily be able to tell the difference between the two. Take some time now, if you haven't already, to fill in your guidebook with the information I've given you and the notes you've taken from the video. Do not complete the introducing Maxon portion yet. We're about to get to that. Now I want to introduce this concept of Maxon. Maxon is a sampling technique used to measure relative fish abundance in an area. Now, for y'all to fully know what that means, we need to define abundance. Abundance is how many fish are present in one area, or more specifically, how many of one species is present in one area at one time. Maxon is the maximum number of individuals in a certain species that can be seen in one video frame. Now that can sound confusing, but I'm going to explain it. One video frame is any 1 second when the video can be paused. Videos are made up of thousands of frames, and throughout these videos, fish are swimming by. So, the Maxon is the maximum number of fish in a species that can be seen if you pause the video. We are going to walk through some examples to try to grasp this concept. Here is our first example picture I want you to study. I want you to study it and determine the number of spot-tail pinfish and Spanish hogfish that you see. I'll give you a little bit to figure that out. Okay, so let's walk through and see the number of fish we have in this video frame. There's 1, 2, 3 spot-tail pinfish. You can distinguish these from the other random fish in the frame because of that black caudal peduncle spot. Also, the black spines along their back. There is 1 Spanish hogfish in the top right corner. Maxon will become more easy to measure once the video starts going, because then you will have context clues. For instance, in this video frame, you may not have known that the fish at the bottom of the picture was a spot-tail pinfish. But if you go past this frame in the actual video, you will later be able to see that it is a spot-tail pinfish. Measuring Maxon and requires a lot of rewinding and replaying of video frames to determine the accurate number of fish. Don't worry if you didn't get this one right. We're going to try another example. Some Maxon values are harder to measure because of the camera angle. Make sure you check all areas of the screen. This video frame was taken after the previous one. What is the current Maxon value for spot-tail pinfish? I'll give you a little bit to decide. All right, the correct answer is actually 4. So here are the 4 spot-tail pinfish that you can see. They are all in the upper right-hand corner. There's 1, 2, 3, and 4. There's also a fish to the left of that 4th one, but it looks like a different shape and you cannot see any defining spot-tail pinfish characteristics on it. So don't just assume that any random fish is the one you're looking for. You can tell that all of those are spot-tail pinfishes because you can see the caudal peduncle black spot on all of them. Let me explain the reasoning for why I put each answer. If you put 0, that means you weren't looking hard enough and you forgot to keep your Maxon number from the previous video frame. If you put 3, that means you either missed one of the pinfish in the corner or you used the same answer from the last video frame. If you picked 7, you have added the max-in of the previous frame and the max-in of this frame together. You do not want to do this. This will give you inaccurate max-in values. Every time you see a video frame with a higher number of a certain species of fish, count those fish and replace your previous max-in number with the number of fish you just counted. Now you're going to try it on your own. You're going to watch this video and record max-in the second portion of your guidebook worksheet. Feel free to adjust the playback speed if needed to slow the video down. Don't get frustrated, the first time is always the hardest. Now that you've collected your max-in data, I want to talk about why this is important. Max-in and measuring abundance can show seasonal patterns of fish or migrations. Migrations can occur to the north or to the south. It varies depending on species. Taking max-in values over a long period of time can show indicators of biodiversity. Biodiversity is the variety and abundance of life within a system, and it is used to measure the health of the environment, and high levels of biodiversity increase productivity in a system. So why are we measuring ocean biodiversity? Why do we as humans care? This is something I want you to dwell on and something we will address more in our second worksheet. Think about all the benefits that the ocean has on our world. But just the one data set we have from today isn't enough to show really anything. It's not accurate data because accurate data is produced from a large data set over a long period of time. Patterns begin to emerge and solidify after long periods of data collection. In small data sets, outliers can have a bigger influence on the average. Taking data over a longer period of time ensures that there is more average and normal data than outliers. Tomorrow, we will take more max-in data and try to develop some meaningful data about these fish species.